All right, so what I'm gonna do is demonstrate what goes on in your stomach. So in your stomach, you have stomach acid, which soda is gonna represent our stomach acid this time. It's not the same type of acid, but it'll do the same job. Now, keep in mind, you're supposed to have acid in your stomach, otherwise you can't break down your food. And so what's gonna happen might look a little gross, but it's actually a good thing. So I'm gonna go ahead and put some soda in the jar. And for those of you in my class, you'll notice it's Pepsi. I'm not gonna waste the Diet Coke. All right. And I'm gonna go ahead now and add milk. So milk is gonna be the food we would eat or drink and see what our stomach acid will do. It's not gonna happen immediately. You can see a little bit of what's going on. It's starting to mix with it. And that is probably enough. All right, so you can already see that something's happening in there. What exactly, we don't know yet. But there definitely is some sort of reaction. Okay, so the reaction's been happening for a couple minutes, and you can start to see that the milk is actually being broken down by the acid. I also notice it's a lot lighter in color now than the original soda. So we're gonna let it completely finish the reaction and everything will settle into a couple layers, and I'll show you that at the end. Okay, so the soda's been sitting for a while, and you can see it looks quite a bit different than it did when we first started. What's happened is the acidic nature of the soda has started to break the milk into its components. So what you have down here at the bottom is calcium phosphate. Now, the acid in soda is phosphoric acid. And so the phosphate in that acid has separated and bonded with the calcium in the milk. It's denser, it's heavier than water, so it's sink to the bottom. What you have up here floating is some of the fat compounds. I used whole milk, so there's more fat than normal milk, and so you've got more sitting up at the top. The coloring, the food coloring that they use in soda, binds with both of those, or sticks to both of the compounds, and so that's why it's dark on top and bottom. And I'm going to take this away from the light here for a minute so you can kind of see a little bit more of the color. And so it's got a little bit more of that brown aspect. And the reason this isn't completely clear like water is there is still quite a bit of sugar that is dissolved in the water in the middle. This is similar to what's going to happen as we start to digest milk in the human body. In the stomach acid is going to break up the different parts of milk, but they don't all get dissolved or completely broken down in the stomach. The fat and the calcium are going to get broken down in your small and large intestine, and that's where your body will absorb them. So this one's a little more gross than yesterday's, but also kind of interesting. I'll see you tomorrow.